And then finally, we have question 6. Now 6 is just another type of question when you could essentially subtract one half equation from the overall to get the other half. In this case, which is a lot faster, but obviously you can balance it from scratch if you want. But sometimes this is faster. In this case, the overall is this, and this is oxidation, so I need to subtract it to get to reduction. A few things you need to do when you subtract. First of all, you need to make sure that the substance that's present in the oxidation half equation matches its coefficient in the overall. So if there is one zinc in here, I should have one here, one in here and one in here. So when I subtract, essentially what happens is the zinc is going to cancel out. The zinc hydroxide is going to cancel out. Anything that is in the overall, it's going to appear in the reduction. So I have to have 2MnO2. So all right, so I've taken care of that. The H2O, which is not in the oxidation but is in the overall, has to also be from the reduction, and the Mn2O3 will also appear in the reduction. Now the only two things that are left is the hydroxide ion and the electrons, which appears in the oxidation but not in the overall, which is another way of saying that when you add the two half equations together, they cancel out. So I need to put it on the opposite side. So if you have two hydroxide ions on the reactant side in oxidation, you must have two in reduction. So when you add them together, they cancel out, which is why they don't appear in the overall equations. And the same can be said for the electrons. Now you've done everything correctly. You should have a balanced equation with everything being balanced. So the charge is definitely balanced with 2 minus on each side. 2 manganese, that's 4, 5, 5, and 2 hydrogen. So I think that is that for part A.